This is Functionkey. In this video we will look at IPv4. Subnetting in IP classes, a comprehensive guide. The Internet Protocol version 4, IPv4, is the foundation of network communication, enabling devices to identify and locate each other on a network. One of the critical aspects of IPv4 is subnetting, which helps in organizing and managing networks efficiently. This video will look into the different IP classes, Class A, B, C, D, and E, and their roles in subnetting. But before we begin, let's look at this IP address. 192.0.0.11. In our Functionkey IPv4 calculator, it falls within the Class C range. Here are some details about it. IP address structure. A Class C IP address has the first 3 octets, 24 bits, designated as the network part, and the last octet, 8 bits, as the host part. In the case of 192.0.0.11, network part, 192.0.0. Host part, 11. Network and host identification. For the IP address 192.0.0.11, the network is 192.0.0.0, and the specific host within that network is identified by the number 11. This means that within the network 192.0.0.0/24, the address 192.0.0.11 refers to a specific device. Subnet mask. The default subnet mask for a Class C network is 255.255.255.0. This subnet mask indicates that the first 24 bits are used for network identification, and the remaining 8 bits are used for host identification. Usable IP range. In a typical Class C network, with subnet mask 255.255.255.0, the usable IP addresses range from 192.0.0.1 to 192.0.0.254. 192.0.0.0 is the network address, and 192.0.0.255 is the broadcast address. In summary, the IP address 192.0.0.11 is a Class C IP address that identifies a specific host within the network 192.0.0.0/24. It follows the typical structure and characteristics of Class C addresses, providing a small number of usable IP addresses for smaller networks. So, what is IPv4 subnetting? Subnetting is the process of dividing a larger network into smaller, more manageable subnetworks or subnets. This technique enhances routing efficiency, improves security, and optimizes the use of IP addresses. Each subnet operates within a specific IP address range, defined by a subnet mask. Now, IPv4 addresses are divided into 5 primary classes: A, B, C, D, and E. Each class has a distinct range and purpose. Class A, designed for very large networks. Class B, suitable for medium to large networks. Class C, ideal for smaller networks. And Class D, reserved for multicast groups. And finally Class E, reserved for experimental use. Now let's look at Class A. Range, 1.0.0.0 to 126.0.0.0. Default subnet mask, 255.0.0.0/8. Network and host bits, 8 bits for the network, 24 bits for hosts. Number of networks, 128, 2 to the power of 7-2, accounting for reserved addresses. Hosts per network, over 16 million, 2 to the power of 24-2. Class A addresses are allocated to very large organizations and ISPs, Internet Service Providers. They provide a massive number of host addresses within a single network. Next, we have IPv4 Class B subnet with a range of 128.0.0.0 to 191.255.0.0. With a default subnet mask, 255.255.0.0/16. Network and host bits are 16 bits for the network and 16 bits for hosts. The number of networks, 16,384, 2 to the power of 14-2. With hosts per network, 65,534, 2 to the power of 16-2. Class B addresses are used by medium to large-sized networks, such as universities and large businesses. They offer a balance between the number of networks and hosts per network. Next, we have IPv4 Class C subnet with a range of 192.0.0.0 to 223.255.255.0. With a default subnet mask, 255.255.255.0/24. Network and host bits are 24 bits for the network, 8 bits for hosts. The number of networks, 2,097,152, 2 to the power of 21-2. With hosts per network, 254, 2 to the power of 8-2. Class C addresses are the most common and are typically used by small businesses and home networks. They provide a sufficient number of networks and are easy to manage. Next, we have the Class D subnet with a range of 224.0.0.0 to 239.255.255.255. Purpose: multicast. Default subnet mask, not applicable. Network and host bits, not applicable. Class D addresses are reserved for multicast groups, which allow one-to-many communication. They are not used for typical network addressing and lack subnet masks. Next, we have the Class E subnet with a range of 224.0.0.0 to 239.255.255.255. Purpose: experimental. Default subnet mask, not applicable. Network and host bits, not applicable. Class E addresses are reserved for experimental purposes and are not used in general networking. These addresses are typically used for research and development. Finally, in conclusion, understanding IPv4 subnetting and the different IP classes is crucial for efficient network management of network devices like routers, switches, and firewalls. Each class serves a specific purpose, catering to different sizes and types of networks. By mastering subnetting techniques, network engineers and administrators can optimize IP address usage, enhance security, and improve overall network performance. Feel free to ask questions in the comments below and we will respond. Explore more about subnetting, subnet masks, and how to implement them in a network environment. You can find the IPv4 calculator in this video on the Functionkey.org blog posted as the Quick Guide to IPv4. Happy networking! This is Functionkey.